everyone, today we're going to be factoring polynomials. Our learning goal today is to be able to factor the sum of cubes or the difference of cubes. Okay, so I'm always going to factor out the GCF first. Whenever I'm starting a factoring problem, we look for the greatest common factor. And then I choose what to do next based on the number of terms that are left inside the parentheses. Okay, if there's no GCF, then we immediately go to these factoring techniques that I'm about to go over. Okay, so if I'm factoring two terms, I'm going to try to do difference of two squares. Sometimes on my homework solution keys, you'll see dots. That's just an abbreviation for difference of two squares. And I use this rule. If we have a difference of two perfect squares, I'm going to factor using a plus b, a minus b. You could also factor using a minus b, a plus b as well. Okay, you just want the whatever's inside the parentheses to vary by a plus or minus sign. Okay, they'll look exactly the same except for the plus or minus sign. The other technique we can use with two terms that we have not learned yet is difference of cubes. And we'll go over that rule today. And then we also have something for sum of cubes, which again, that's a new factoring technique that we'll talk about today. For three terms, we're going to do trinomial factoring, and we've got some different techniques that we can use for that. My go-to is always guess and check. I'll put a star by it. Especially if the leading coefficient is 1, it's pretty easy to quickly factor using guess and check. However, when the leading coefficient's not 1, sometimes it takes a while to guess and check your answer. In that case, you could use split the middle or X method to factor your trinomial. Okay. Factoring four terms, we're going to use factoring by grouping for that. And remember, after you factor, you always want to check each factor to see if you can do more factoring. Okay? Always look at each factor, whatever's inside the parentheses, and see if you can do more factoring. It says a polynomial is factored completely when it is written as a product of unfactorable polynomials with integer coefficients. This means you have to do several factoring techniques to get the complete factorization at times. Okay, you may have to do more than one factoring technique to get the complete factorization. Okay, see factoring flow chart on the next page. So we're going to follow this flow chart. Okay, my start, we say, is there a common factor, right? If there's a GCF, yes, then I'm going to factor out the GCF. If there's not one, then I move on to the question, how many terms are there? Okay, once we get to the number of terms, you can either have 2 terms, 3 terms, or 4 terms. If there's 2 terms, we might ask ourselves the question, is it a difference of 2 squares? Could also possibly be a difference of cubes, or it could possibly be a sum of cubes. So we've got to figure out which one it is. If we've got 3 terms, we're going to factor it into 2 binomials. Remember, with this, we can either use guess and check, split the middle, or X method. So I'm going to just put a note in here that this might mean guess and check. This could mean split the middle. Or you could use X method. So any one of those that works best for you, you're welcome to use. So you can see in this example, it's going to factor to x minus 7, x plus 3, right? If you have something that's more complex where you've got a value that's something other than 1, it might be hard to guess and check on that kind of problem. So you might want to use split the middle or X method to help you. If my expression has 4 terms, then we're going to do factoring by grouping. Okay, we did a lot of 2 by 2 grouping where we split it up into 2 groups and factored out the GCFs of each group, right? Whatever was in common, we factored out as the GCF. We wrote it once, and then whatever was left over got smushed into that second set of parentheses, right? If you watch my enrichment video, we also talked about 3 by 1 grouping, where we do 3 terms in one group and then 1 term in the other group. If you did not watch the enrichment video, feel free to go back and watch that, okay? But that is a challenge to do factoring by grouping with a difference of squares. Okay, and then once we figure out whether there's 2, 3, or 4 terms and what factoring technique to use, remember at the very, very end, this is really important, you need to check each factor and ask yourself the question, can it be factored again? If the answer is yes, then repeat one of the factoring methods. If the answer is no, then you're just going to circle your final answer. Okay, so in example 1, we're factoring using GCF. It says finding a common monomial factor. So in this first one, what are all 3 terms divisible by? Well, I see with constants a 1, a 4, and a 5. Those don't share any common factors other than 1. But for the variable, remember we choose the lowest power. So in this case, the lowest power is x to the first. So I'm going to divide all of them by x. All terms are divisible by x. We write the GCF out front. Here we'll subtract these exponents and get x squared. Again, subtract these exponents, so we get 4x to the first, right? 2 minus 1 would be 1. Okay, but I don't need to write the to the first. And then x divided by x, those cancel, right? This would really be like 5 times 1, so we're just going to have 5. All right, I started with GCF factoring. I'll make a note of that. Now I've got to look inside this parenthesis and ask myself the question, can any more factoring be done? Yes, that's a trinomial. So I am going to factor that trinomial. I'll go ahead and do that in red. Okay, first times first is x squared. What times what is x squared? X times x is x squared. Okay, last times last has to multiply to give me 5. What's going to multiply to give me 5? Really, we don't have many options, 5 and 1. Okay. Because this was a negative sign, I know that these signs are going to have to alternate. They're not going to be the same. So which number is going to be negative? The bigger number is going to have to be negative so that I get a -4 in the middle, right? We're asking ourselves what multiplies to give you -5, but adds or sums to give me -4, and that would be -5 plus 1. Okay, and this is trinomial factoring. Here I just use guess and check. It's pretty easy because that leading coefficient was 1. We can see that first times first is x squared, outer times outer is x, inner times inner is minus 5x, which does sum to -4x, and then last times last was -5, which is exactly what I had. Okay, then I look within each one of these parentheses and I ask myself, can I factor it more? Can I factor x minus 5 anymore? No. Can I factor x plus 1 anymore? No. So that is completely factored. All right, going on to the next one. Use GCF first. What are they both divisible by? It looks like they're both divisible by 3. Okay, and then we'll use the lower power of y cubed. Okay, so I'll factor out a 3y cubed. 3 divided by 3 is 1. Here, if I subtract the exponents, we'll get y squared. 48 divided by 3, what is that going to be? That's going to be 16. And y cubed divided by y cubed, those cancel out and give me 1. I could write times 1 if I wanted to, but it's not necessary. Anything times 1 is just itself. Okay, so I got that from doing GCF factoring. Now I have to look inside the parentheses here and ask myself, is there anything else I can do? Yes, there is. This is a difference of 2 squares, right? So I'm going to keep my GCF out front, but then I'm going to factor this using difference of 2 squares. So what's y squared a perfect square of? Y. What's 16 a perfect square of? 4. So I'll have a plus b, a minus b. Okay, and again, this was a difference of 2 squares that allowed us to factor it like that. So we get 3y cubed times y plus 4, y minus 4. And I look inside each parenthesis. This is a binomial now. So really, can I use difference of squares, cubes, or a sum of cubes to factor that more? I cannot. Okay, so that would be our answer. All right, last but not least, over here, we'll ask ourselves what all of these terms are divisible by. Looks like they're all divisible by 5. And the lowest power here is z squared, right? I don't want to choose something like z cubed, because if I did z cubed, see how here we'd get 1 over z. I want it to divide evenly. Okay, so we're going to use z squared instead, because all of the terms will be divisible by z squared. So if I do 5, and you know what, when we're writing the z's, let's be really careful so they don't look like 2's. I'm just going to put like a little line through them so that we know that those are letters. 5z with the little line through it, squared. 5 divided by 5 is 1. Here, if I subtract the exponents, I get z squared. 30 divided by 5 is going to be 6. Z cubed divided by z squared is z to the first. Plus, what's 45 divided by 5? That's going to give me 9. And here the z squareds cancel to give me 1. Okay, so we get that. 5z squared times the quantity z squared plus 6z. I didn't put my little line through it. Dink, plus 9. Okay, now I have to look inside the parentheses and ask myself, can I factor that more? I sure can. Once I get done with the GCF factoring, I'm going to do trinomial factoring. Okay, you can pick, guess and check, split the middle, X method, whatever you like. Because it's a leading coefficient 1, it's going to be pretty easy to do guess and check. So we'll have 5z squared. I'll set up my parentheses, set that up in red. Again, we're trying to factor this right here. What times what is z squared? It's going to be z times z is z squared. What are some things that multiply to give you 9? 1 and 9, 3 and 3. Look back. What's going to help you get to 6? 3 and 3. Because these are all plus signs, that means that we're going to use all plus signs in the factored form as well. Okay, so you can leave your answer like this. Or if you want to write this perfect square trinomial as z plus 3 quantity squared, you could write it like that as well. Okay, so either answer would be just fine. Okay. What do we have next? Special factoring patterns. So we've got our sum of 2 cubes and difference of 2 cubes. Okay, so sum of cubes, we'll see a cubed plus b cubed. Difference of 2 cubes, you'll see a cubed minus b cubed. Okay, so it literally just depends on if we see a plus sign or a minus sign. Okay, let's look at the patterns here. If we've got a sum of 2 cubes, notice that my first sign is plus, my next sign is minus. So it's like same, opposite. Okay, here if we have a difference, look at how my first symbol that I use is minus, and then my second one is plus, right? Same, opposite, right? If we start with a plus, I start with a plus. If we start with a minus, I start with a minus, and then this is opposite. Okay, I'm just trying to recognize those patterns. You don't have to memorize these formulas. This is something where on the test or quiz I would give this to you, but the more familiar you can become with the patterns, the faster your homework will go. So just something to keep in mind. So if I've got 64x cubed plus 1 and I want to factor it, ask yourself, what is 64x cubed a perfect cube of? What times what times what equals 64? That's going to be 4 times 4 times 4. What times what equals x cubed? It's going to be x times x times x. So you can see 64x cubed is a perfect cube of 4x. Okay. If I want to know what 1 is a perfect cube of, think what times what times what equals 1. That's going to be 1 times 1 times 1 equals 1. So it's a perfect cube of 1. Okay, so I'd be using an a value equal to 4x and a b value equal to 1. Okay, and you can see how I plug it into my formula. Instead of a plus b, I have 4x plus 1. Right, if I square 4x, I would get 16x squared minus ab. If I multiply these together, I get 4x. And then I have b squared, which if I square 1, I get 1. Okay, so we're going to do some of those examples together. Difference of cubes works the same way here. Like if I've got 27x cubed, I have to think to myself, what is that a perfect cube of? Well, 3 times 3 times 3 is 27. X times x times x is x cubed. What's 8 a perfect cube of? 2 times 2 times 2 is 8. Okay, so you can see how I replaced a with 3x and b with 2. If I square 3x, I'd get 9x squared. If I multiply them, I get 6x. And then if I square b, I get 4. Okay, so that's how you plug it in. Let's try some of these on our own. Okay. In order to help us, let's list our perfect cubes first. So I'm just going to think to myself, like, what's 1 cubed? What's 2 cubed? Let's go all the way through 10. Okay, 1 cubed is 1. 2 cubed is 2 times 2 times 2, which is 8. 3 cubed is 3 times 3, which is 9. 9 times 3, which is 27. 4 cubed, let's see, 4 times 4 is 16, and 16 times 4 is 64. For 5 cubed, we have 5 times 5, which is 25. And then if I multiply that again by another 5, I would get what? 125. 6 times 6 is 36, which if I multiply by another 6, I think I get 216. I think that's right. All right, I'm going to grab my calculator now just so that I can plug these into my calculator. All right, let's do 7 cubed in our calculator. That's going to be 343. 8 cubed in my calculator is going to be 512. 9 cubed is going to be 729. And then 10 cubed, we're going to put the 1 and we're going to put 3 zeros. Okay, so that's going to be 1,000. Okay, so now that we've thought about our perfect cubes, let's go ahead and answer these questions. Does this first one have a GCF? No. So I'm going straight to 2 terms. I can either pick difference of 2 squares, difference of cubes, or sum of cubes. It's not a difference of 2 squares because x cubed is not a perfect square. And if I'm debating between difference of cubes or sum of cubes, it's going to have to be a difference of cubes because that minus sign. Okay, so let's go ahead and use difference of cubes. All right, let's practice writing the formula for difference of cubes. So the difference of cubes formula is equal to what? Well, because this is a difference, my first parenthesis is going to be a difference. And then remember my second parenthesis opposite. So we'd have a squared. This is going to be plus ab plus b squared. Okay, now in order to plug into this formula, I have to know what a is equal to and what b is equal to. So in this case, what is x cubed a perfect cube of? Right? Or what is the cube root of x cubed? That's going to be x, right? X times x is x cubed. Awesome. And what is 125 a perfect cube of? Or what is the cube root of 125? If you're not sure, let's look at our list over here. What is 125 a perfect cube of? Looks like it's a perfect cube of 5. Okay, so I'm going to go back here and I'm going to say that this is a perfect cube of 5. All right, and then I'm going to plug in what I know. Let's start by plugging in something for a. We're going to get x if we plug that in, minus, which I put a minus sign already. B, what's b? B was 5. Okay, now I have a squared, so I'm going to put x squared plus, right, there's a plus, ab, right, we're going to multiply a and b together. So I have a was x and b was 5, and then plus b squared plus, let's see, b was 5, and I'm going to square it. Okay, so I'm just using my rule and replacing everywhere I see a, I replaced it with x, and everywhere I see b, we replace it with 5. And you can see why the substitution practice at the beginning of the year was so helpful. It's because we're using substitution throughout the year. Okay, x squared is x squared. X times 5 is going to be 5x, and then 5 squared is 25. Excellent. Okay, then I have to look inside each parenthesis and ask myself, can I factor it more? Can I factor x minus 5 more? No. Can I factor this trinomial more? Well, I don't know. Let's see. I'm going to do x minus 5, and we're going to see if we can factor this guy more. X times x is x squared. What times what is 25? Either 1 and 25 or 5 times 5. If I put 5 times 5 here, you can see my outers and inners give me 10x when I sum them together, which is not going to work, right? Because I have a 5x in the middle. And then if I do 1 and 25, let's try that. Here my outers give me 25x and my inners give me 1x. So that's either going to be like, yeah, it's going to be 26x. So that doesn't work. So you can see I cannot factor this any further. So this is going to be my answer right here. Let's head over here to part B. What's the first thing we always look for? GCF. Does this have a GCF? Well, what are 16 and 54 both divisible by? I know they're at least both divisible by 2, right? Because they're even. See how this is an even number and this is an even number? I wonder if they're both divisible by 4. Like I know 16 is divisible by 4. Is 54 divisible by 4? No, we get 13.5, that's a decimal. So 54 is not going to be divisible by 16 either. So I think the biggest number they're both divisible by is 2. Then if I look at my variable, I'm not going to choose s to the 5th because otherwise I'd end up with a fraction. We're going to have to choose the lower of the two exponents. So we'll have s squared. Okay, so let's factor out that GCF. 2s squared. 16 divided by 2 is 8. Here, if I subtract the exponents, we would get s cubed plus 54 divided by 2 is going to be 27. Is that right? 27. And then s squared divided by s squared, those cancel out. They just give you 1. Okay, so there we go. That is GCF factoring we use there. And then I have to look inside and ask myself, can I factor that anymore? Well, it's 2 terms. So I'm either looking at difference of squares, sum of cubes, or difference of cubes. Anything that's a difference, it's not going to be because I see a big old plus sign in there. So the only possibility might be sum of cubes. So I'm going to ask myself, what is 8s cubed a perfect cube of? What's 8 a perfect cube of? Or what's the cube root of 8? That would be 2 times 2 times 2 is 8. What's the cube root of s cubed, or what is s a perfect cube of? S. Okay. If you're not sure about the constant, go over here to our little chart, and you can see that 8 is a perfect cube of 2. Okay, what about 27? 27 is a perfect cube of 3. Right, so if I'm thinking, what is 27 the perfect cube of? It would be 3. So now I know what to plug in for A and what to plug in for B. Okay, let's keep in mind what our what our sum of cubes formula is. A cubed plus B cubed equals. Remember, it's going to be the same symbol inside the first parenthesis. See how that's a plus? Awesome. And then opposite in the second. So we'll have A squared minus AB plus B squared. Okay. So everywhere I see an A, I'm going to be plugging it in for A in my rule. And everywhere I see a B, I'm going to be plugging it in for B in my rule. I just did watermelon colors. I didn't even realize that. Okay, so let's go ahead and try to factor it. My GCF is just going to stay out front, 2s squared. And then I need to fill out these parentheses. So we start with A. So I'll have 2s plus B, which what was B? B was 3. Okay, in the second parenthesis, now I have A squared. So I'm going to write 2s squared. Make sure you put parentheses. Okay, if you don't put parentheses around it, you won't remember to square the 2. Okay, so make sure you got those parentheses. All right, minus comes next. AB, A was 2s, B was 3. I might need a little bit more room. plus b squared. B was 3, so 3 squared. Okay, and then we just have to simplify this. We have 2s squared. This is going to be 2s plus 3. Right, if I square both of these parts, right, if I square 2, I get 4. If I square s, I get s squared. Remember, when you're squaring something, really what that means is you're multiplying that something by itself. So that's another reason why we would have 4s squared. Minus 6s plus 3 squared is 9. Whew! Okay, so we just got done with our sum of cubes factoring technique. Now I've got to look inside each parenthesis and make sure that I can't factor it more. So can I factor, I'll do this, what color do I want to use? Yellow. Can I factor 2s plus 3 anymore? Nope, it's not a sum of cubes. Can I factor this trinomial anymore? Well, I don't know, let's try. We'll see if we can. Because it's a leading coefficient of 4 and there's some different options, like we could do 4s and s, or we can do 2s and 2s, because there's just some different options, right? This could multiply to be 1 and 9 or 3 by 3. Rather than wasting the time guessing check factoring, let's go ahead and do X method and just see if this is factorable. Okay, so remember, we're going to do AC. 4 times 9 is 36. Then my middle is -6. My leading coefficient is 4, so we put this over 4. Okay, and my question is what multiplies to give you 36, but sums or adds, right? Sums or adds to give me -6. Is there anything that multiplies to give me 36, but sums or adds to give me -6? Well, what are some things that multiply to give me 36? Like 9 and 4. We would have 6 and 6, 1 and 36, right? If I maybe did -9 and plus 4, right? That would be -36, right? But it's not positive 36. That's the only way I can get it to sum to -6, though, is if I did -9 and positive 4. If I made them both negative, then we'd run into a problem, right? Because I wouldn't end up with a -6. I would have negative, what, 13? So that doesn't work. I also can't use 6 and 6 because that's not going to get me to -6. Can't use 1 and 36 either. That's not going to get me to -6. So is there anything else that 36 would be divisible by? Let's see, 36 divided by 2 is 18. But that's not going to get me to -6 when I sum. Trying to think, 36 divided by 3, 3 and 12. Could that work? No, that's not going to get me to -6. 36 divided by 4 was 9. We already listed that. 36 divided by 5 is a decimal. 36 divided by 6 is 6. We already used that. Yeah, I'm kind of out of options here, guys. So this is not factorable. And that's pretty typical whenever you're using sum or difference of cubes. Once you use sum or difference of cubes, most likely that trinomial is not going to be factorable. So I'm not surprised. Okay. All right, so that's where we're going to stop there, is the 4s squared minus 6x plus 9. It sounded like I said x, but s is what I was trying to say. Okay, student practice, factor the polynomial completely. So here we're going to use sum of cubes. And over here, it looks like we're going to use GCF and difference of cubes. So pause the video and see if you can do those on your own. I go through these pretty quickly. Here, a cubed is a perfect cube of a. Here, 27 is a perfect cube of 3. Okay, so I'm going to keep the same sign in the first parenthesis, and then I'll have a squared, opposite sign, times a times 3, plus b squared, which would be 3 squared. Okay, so I have a plus 3, a squared minus 3a plus 9. And then we look in here to see if it can be factored anymore. In this case, it cannot. And like I said, this is going to be pretty typical when you're using sum or difference of cubes, that trinomial will not be factorable. Okay, here my GCF is what? What are both of these divisible by? Let's see, is 750 divisible by 6? It absolutely is. You get 125. Okay, so they're both divisible by 6. Then we'll use z squared. They're both divisible by z squared. Okay, 6 divided by 6 is 1. Here, if I subtract the exponents, we'd get z to the third power. Again, 750 divided by 6 is 125. And then this z squares would cancel out to give you 1. Okay, so this is going to be a difference of cubes, right? Where z cubed is a perfect cube of z, and 125 is a perfect cube of 5. So we'll get 6z squared. Remember, in the first parenthesis, we use the same sign. So I'll do a minus b, which is z minus 5. Then we have a squared, which is z squared. Opposite sign, so plus ab, or in this case, z times 5, plus b squared. So if I square 5, it would look like that. So we get 6z squared times z minus 5 times z squared plus 5z plus 25. Okay, again, look to see if that trinomial is factorable. We know it's not going to be typically, just because we're working with a difference of cubes there. Okay, moving on down to factoring by grouping. We're going to factor this completely. This is a review. I'm going to do 2 by 2 grouping. So you can either underline, or if you like to put the parentheses around it, you could do that. In the first group, both terms are divisible by z squared. Z cubed divided by z squared is z. 5z squared divided by z squared is 5. Okay, remember, we want the second parenthesis to match. So I have to think, what can I factor out to get that second parenthesis to match? Well, if I factor out a -4, then I would get z plus 5, which works, right? If I had not factored out a -4, like let's say I factored out a +4, in my parentheses, I would have gotten negative z minus 5, which you can see does not match. So you'll know whether or not you did it right, because that parenthesis needs to match. So I'll, again, factor out the -4 instead of the +4, because that seemed to work. Okay, we got z plus 5. Right, factor out a GCF again. What do both of these terms have in common? They both have a z plus 5. And then what would be left if I factored out a z plus 5? We would get z squared minus 4. Okay, and that's the end of factoring by grouping. But remember, we still have to look inside each parenthesis and see if I can factor further. Can I factor z plus 5 further? No. Can I factor z squared minus 4 further? Absolutely. That's a difference of 2 squares. Okay, so I'm going to leave the z plus 5 alone, but I'm going to factor the z squared minus 4. Right? We're going to do a plus b, a minus b. So we're going to do z plus 2, z minus 2. Okay, and that was difference of 2 squares. If you look in each one of these parentheses, it cannot be factored any further. Okay. Just have a quick note here for you guys. It says, if factoring by grouping doesn't work when you group the first 2 terms and the last 2 terms, reorder the 4 terms and try factoring by grouping again, just to see if you can factor if you put different things in different groups. If you want an example of this, you can see enrichment example number 1 at the bottom of this note page. Okay, the enrichment example is going to involve either the sum or difference of cubes. Okay, so it would be a good idea to watch this enrichment example, because you'll see what I mean. We'll have to reorder some terms in order to get the grouping to work. All right, before we get to the enrichment, let's go ahead and go through example 4, which is mixed review. We're going to use our factoring flow chart here. Remember, the first thing I always try is always GCF. Is there a GCF for this expression? Is there anything they're both divisible by? Well, the factors of 16 are what? 1 and 16, 2 and 8, 4 and 4. Okay, is 81 divisible by 16, 8, 4, or 2? Is 81 divisible by 16? No, I get a decimal. Is 81 divisible by 8? No, I get a decimal. 4, I get a decimal. 2, I get a decimal. Okay, so no GCF. All right, now what could this be? Is this difference of squares, difference of cubes? What are we thinking? Is 16 a perfect square or a perfect cube? 16 is a perfect square, so I'm thinking to myself, okay, difference of squares. What is 16x to the fourth a perfect square of? Well, 4 times 4 is 16, and x squared times x squared is x to the fourth. What is 81 a perfect square of? 9. Okay, so I'm going to make my a value 4x squared, and my b value is going to be 9. Right? Difference of two squares, we use a plus b, a minus b. So I'm going to have 4x squared plus 9, 4x squared minus 9. Okay, and once I do difference of two squares, I have to look and see if I can factor further. Can I factor 4x squared plus 9 anymore? Is it a difference of squares? No, it's not a difference. Is it a sum of cubes? 4 is not a perfect cube, so no. Is it a difference of cubes? No, it's not a difference. Okay, so I'm done with that. What about this one, 4x squared minus 9? That's a difference of squares again, right? So I'm going to leave my 4x squared plus 9 alone, but this factor right here, I'm going to break up using a difference of two squares again. Okay, 4x squared is a perfect square of 2x, and 9 is a perfect square of 3. So I'm going to have a plus b, a minus b. All right, and that's it. That's going to be my answer. Can't factor 4x squared plus 9 anymore. Can't factor 2x plus 3 anymore. And 2x minus 3 is not a difference of squares either, right? 2x is not a perfect square. All right. Last but not least, does part B have a GCF? Yes, they're all divisible by at least 3. Okay. And then what power of p do they have in common? They're all divisible by p squared. Okay, so let's factor out a 3p squared. That's going to end up being what? P to what power? 8 minus 2. It's going to be p to the 6th. Plus, let's see, 15 divided by 3 is going to be 5. Here, if I subtract the exponents, we get p to the 3rd power. And last but not least, what's 18 divided by 3? That's going to be 6. And then the p squareds cancel, right? Okay, so we got that using GCF factoring. Now I have to look and see if there's anything else I can do. Looking inside of here, we're going to try trinomial factoring. Because the leading coefficient is 1, I'm just going to try guess and check. Okay, so again, I'm taking this set of parentheses and I'm seeing if I can break it up into two binomials. What times what is p to the 6th? Let's use p cubed and p cubed. Right, when I multiply like bases, I add the exponents, right? 3 plus 3 is going to be equal to 6. Okay, then what times what would give me 6? What can I multiply to get 6? That would be 1 and 6 or 2 and 3. So either one could really get me to 5, right? 1 and 6 or 2 and 3. So let's say I did 1 and 6. I also am making the observation that every sign is positive here. So that means that every sign would have to be positive there. Let's see if that multiplies to give us what we want. We have p cubed times p cubed, which is p to the 6th. My outers are 6p cubed, and my inners are 1p cubed. Ooh, that's 7p cubed, right, if I add those together. So that's not going to work. So I am not going to use 1 and 6, it looks like. Let's try 2 and 3 instead. Remember, 2 and 3 seems like it could also get us 5. So my outers here would be 3p cubed and my inners here would be 2p cubed. So that looks like that works. That does sum to 5. Okay, that's what I'm going to use instead. So my answer is going to be 3p squared times p cubed plus 2 times p cubed plus 3. Now, why could I not use sum of cubes for these factors? Because 2 is not a perfect cube and 3 is not a perfect cube. So I cannot factor that anymore using sum of cubes. Okay, so we're done.